Good morning, students. How are you? Have your breakfast? Let's start our lesson. Okay. Before starting the lesson, let's see the quote. உன் வலது கை செய்கிறதை உன் இடது கை அறியாதிருக்க கடவுது. Okay. Today we are going to see the continuation and the last topic of the lesson, magnetism. Magnetism, that is bullet train. Bullet train or electromagnetic train. We are going to see about train. Okay, train, different types, a train that is going to come to India in the recent days. Okay, bullet train or electromagnetic train. See here. This is a electromagnetic train or maglev train. And we are going to see the working, construction and the usage and which of the countries are using this magnet, and we are going to see. Okay, first, it is an electromagnetic train. It is an electromagnetic train. Electromagnetic. See the word clearly. Electro and magnetic. So we can separate the word into two. That is electro as well as magnet. Electro means it shows the electricity, current, electricity. Magnet means it shows the magnetic property, magnet. Okay. So in this electromagnetic train, they use two property in the combined manner, that is electromagnetic. Okay. The other name of electromagnetic train is suspension train or flying train. Suspension means what? Suspension. Example, in Tamil we can say medakkurathu. Okay, suspension or flying train. Suspension or flying train. The other name of electromagnetic train is suspension train or flying train. This train is not at all worked by means of diesel or petrol. Like a bike, like a car, like a lorry, like a bullet train, like a normal train, like other normal train. It is not at all worked by means of petrol or diesel. It is worked by means of only that is magnet. Okay. So in the last class we have seen that the magnet have two property into it. That is, what are the properties of magnet? What are the properties? I have explained in different. I have explained by using a chart also. Yes, that is attraction as well as repulsion. By using only these two property, they have created this maglev train or electromagnetic train. Okay, let's see the working of electromagnetic train. Let's see the working of electromagnetic train. Okay, and before that, I'm drawing a diagram. See carefully. Before that, I'm drawing a diagram. I'm drawing a diagram. See, wait for a minute. After this diagram, you can understand very much clearly. Black shows North Pole. Okay, black shows North Pole, and blue shows South Pole. Blue shows South Pole. This is a railway track. The line shows the railway track. Okay, the line shows the railway track. if there is railway track, it must be a train into it, right? So this maglev train or electromagnetic train, that is floating. That is floating. Okay. Wait. Okay. This diagram. The blue color shows south pole, right? Blue color shows south and the black color shows north. Okay. Let's keep the diagram for a minute and I just explain the about electromagnet. Okay. This the electromagnetic train is worked by means of the electric, that is the magnet is magnetized by allowing electricity through the magnet. First point is the magnet is magnetized. See, they keep, this is the line shows the north pole, south pole means that is magnet, only the magnet. And this box also, this shows a magnet. This magnet, first they make the magnet that present the track, and then the train is just magnetized. It just magnetized by means of by allowing electric current through the magnet. First point. And the second one is if they change the direction of current, the direction of poles also change. Okay. If the current pass in this direction, the poles also move in this direction. If the current pass in this direction, the poles also move in this direction. So if the current change, the direction of the poles also get changed. Okay. And also the train. If a train need to move, it must need a railway track, right? Railway track. In the railway track, they arrange magnet, and also at the bottom of the train they keep magnet. At the bottom of the train they keep magnet. In this manner. See, this is a track. This is a railway track. This is a railway track. This black, blue, black, blue, black. Blue, black, blue, black, blue. These are railway track. Railway track, and it is not just a simple railway track. It is a magnetic railway track. These all are magnet. And one magnet shows north pole and other magnet shows south pole. Likewise, the magnet is arranged in systematic manner. Okay, arranged in systematic manner. And if we see the train, and this is a train, okay, and this will be a train. At the bottom of the train also they keep magnet. That is north pole, here south pole, north pole, south pole. They keep a magnet. Okay. And in the last class we have learned that like poles repel each other, unlike poles attract each other. Right? Like poles repel each other, unlike poles attract each other. See here, south. This is south, right? So from here we can see. This is north, and this black color also shows north. So it just what? It just repel each other. It make this magnet and this magnet won't attract. It won't meet. It will move backward, right? It just repel each other. And if you compare with this is the south pole and this is the north pole. It just attract each other. So the train get move. If it is repelling and this is attracting means the train get move. Like in the same manner, here there will be a repulsion. Here it will be a attraction, right? So the train get move. And in below, see here will be a repulsion and here will be attraction. So the train move. here will be repulsion and here will be attraction. So the train get moved. This is the process that is going on in this maglev train. This is the process that is going on in this maglev train. This is a simple thing. This is a simple thing that is present in the maglev train. Okay. The gap between the track as well as the train is 10 meter. The gap between the train and the track is 10 meter. 10 meter is 10 meter. 1 meter is nothing but what? 1 meter is equal to 100 centimeter. So 10 meter means 10 meter is equal to 10 into 100. So 1000 centimeter. So the gap between the train and the railway track is 1000 centimeter or 10 meter. 1000 centimeter or 10 meter. Okay. The train get moves by means of magnet attached at the bottom of the train as well as magnet in the railway track. It get magnetized. It get magnetized when the current allow. When the current allow through this magnet, it get magnetized and it start moving. It start moving. There is no There is no moving parts into it. Moving parts means what? Moving parts. You have here this word moving parts. What's the meaning of moving parts? Example, in bike, what is the moving part? In bike, what's the moving part? Wheel, right? In car, what's the moving part? Wheel, 4-wheel. Car has 4-wheel, bike has 2-wheel. Likewise, in the normal train also there will be a moving part. Yes, it has wheel in it. Yes. So in this maglev train, do not have any moving part, nothing, but it do not have any wheel at all. So if there is no wheel at all or there is no moving part, there will be no friction at all. Friction. What's the meaning of friction? Friction. In Tamil we can say uraivu. Take your palms or take your hands and start rubbing. And start rubbing. Whether you feel any heat or hotness in your hand, that is called friction. Okay, simply we can say this is called friction. So there will be no friction at all. Before we have seen that the gap between the railway track as well as the train will be what? 10 meters. There will be a 10-meter gap. So there is no attachment. There is no friction at all. Okay. And the speed. Normally this train move at the speed of 300 km per hour in 1 hour. In 1 hour, it move 300 km. 300 km. Okay. In 1 hour, it attain 300 km. Normally. But it can move at a speed of 600 km per hour. Normally, it move 300 km per hour. But it can move. It has a capacity to move at 600 km per hour. And main thing, it do not produce any noise at all. It won't produce any noise at all. And it do not require any energy. So it takes only less energy and it is an eco-friendly. Example, if a bike is running the road, whether it harm the atmosphere, yes, we are pouring diesel or petrol into the bike and it just polluting, just releasing carbon monoxide, right? Just releasing carbon dioxide into the air and it's just polluting the atmosphere. Yes. Likewise, it's not at all. It do not. This maglev train is not run by means of diesel or petrol. So it won't pollute the atmosphere. Okay, it is an eco-friendly. And main thing and the main one is this maglev train. This maglev train is used in 3 countries now. Now 3 countries are using this maglev train, that is Japan, China and South Korea. Japan, China and South Korea. Even other countries are making some contribution to run this maglev train as a public transport. These 3 countries, Japan, China and South Korea, are using this maglev train as a public transport. So many persons are moving through this maglev train to their job places, their or relative places. Likewise, they are using this maglev train as a public transport like bus, car, auto, example, etc. And India also, nowadays India also taking steps to keep this maglev train for our future use. Okay students, today we have learned about maglev train, that is bullet train or electromagnetic train, and I have made a railway track. This is normal railway track. Okay, normal railway track. It's not a ladder, it's a railway track. The gap is here, see here, there will be a gap between this track, and this is the track, railway track, and there will be a gap between, see. Okay students, all of you take your book, let's mark the questions. All of you take your book, page number, page number 12, that is Tamil Nadu New Syllabus, Standard 6, Term 3, page number 12. Choose the best answer. I'm marking all the questions. Okay, the last two videos, if someone is not marking it, so you can see from here also. Roman number 1 and the question. See, I'm just marking. You write down this. Question number 1. An object that is attracted by magnet or plane pins. Option B. People who made mariner compass for the first time is option C, Chinese. A freely suspended magnet always comes to rest in the dash direction, north south direction, option D. Question number 4. Magnet lose their property when they are hit with a hammer. Option C. Mariner compass is used to find the direction, option C. Okay. Then Roman number 2. Fill in the blanks. Artificial magnets are made in different shapes such as dash, dash and dash. Oval, O-V-A-L, oval. Disc, D-I-S-C, disc. Cylindrical, C-Y-L-I-N-D-R-I-C-A-L, cylindrical. Second question. The materials which are attracted towards a magnet are called magnetic substances. M-A-G-N-E-T-I-C, magnetic substance. S-U-B-S-T-A-N-C-E-S, magnetic substances. Question number 3. Paper is not a dash material. Magnetic, M-A-G-N-E-T-I-C. Fourth question. In olden days, sailors used to find the direction by suspending a piece of lodestone, L-O-D-E. Lodestone, S-T-O-N-E, lodestone. Question number 5. A magnet always have dash poles, 2, T-W-O, 2 poles. Pause the video and write the answer. Okay. And the third Roman number 3, true or false. If false, give the correct answer. Roman number 3. A cylindrical magnet has only one pole. Answer, false. Cut the 1 and write 2. Second one. Similar poles of magnet repel each other. True. Question number 3. Maximum iron filling stick in the middle of the bar magnet, which is when it is brought near them. Answer, false. And cut the middle. Cut the middle and write both sides. Cut the middle and write both sides. A compass can be used to find east-west direction at any places. True. Rubber is a magnetic material. False. And add magnetic to non-magnetic. Magnetic to non-magnetic. And Roman number 4. I'm just writing only the answer. Compass, magnetic needle. Compass, magnetic needle. Attraction, opposite pole. Attraction, opposite pole. Repulsion, like pole. Magnetic poles, maximum magnetic strength. Magnetic poles, maximum magnetic strength. Okay, pause the video and write. Pause the video and write this. See, all the answers what I have marked is correct, so don't skip it. Okay, and Roman number 5. Roman number 5. Question number 1. Iron nail, pins, rubber band, needle. Round the rubber band. Sorry, around the rubber tube. Lift, escalator, electromagnetic train, electric bulb. Round the electric bulb. Attraction, repulsion, pointing direction. Illumination. Round the illumination. Round the illumination. And Roman number 6. Answer is A and C are same. B and E are same. D and F are same. Okay. Write down the names of substances. Substance attracted by magnet. Substance attracted by magnet. Write down the names. Substance attracted by magnet. Write down the names. In that, plain pins are there. And write needle. 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 Nail. 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 Copper. 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 Iron rod. Iron. Rod. Iron rod. Key. Key. Knife. 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 Safety pin. Safety. Safety pin. Pin. Safety pin. Safety pin. And the substance that is not attracted by magnet. Substance that is not attracted by magnet. This is substance attracted by magnet. And this is substance that is not attracted by magnet. That is chalk piece. They have written chalk piece. Write plastic. 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 Pencil. 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 Glass. 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 Paper. 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 Wax. 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 Wood. 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 Then eraser. 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 Okay. And the Roman number 8. Pause the video and write. Roman number 8. Roman number 8. Question number 1. Roman number 8. Question number 1. Explain the attraction and repulsion between magnetic poles. Page number 6. Explain the attraction and repulsion between magnetic poles. Mark the unlike poles. Mark unlike poles attract each other. Like poles repel each other. Okay. Second one. A student who checked some. Here the page number is page number 6. Here the page number also 6. A student who checked some magnet in the school laboratory found out that the magnetic force is thrown out. Give 3 reasons for that. Page number 6. Mark, do magnet lose a property? In that heading, mark magnet lose their properties if they are heated or dropped from height or hit with a hammer. Okay. Then Roman number 9. Question number 1. You are provided with the iron needle. How will you magnetize it? Page number 6. And mark the activity. Fully mark the activity. Page number 6. How does the electromagnetic train works? Page number 10. Page number 10. From electromagnet, from the first line to second para. First and second para fully. First and second para fully. Okay. That is the answer for electromagnetic train. Working of electromagnetic train. Okay students, from this we finish this magnetism lesson, and I think you have understand what I have teach in all the videos, and your job is to learn. Okay, your job is to learn everything, and if you have any doubt, please maybe comment on it. And thank you students.